Hi everyone, my name is Alison Duncan and the title of my presentation is Effect of Soy Isoflavones on Thyroid Function and Female Reproductive Hormones. Here are my disclosures. And as you know, this session is focusing on a comprehensive review of the literature about soy isoflavones and hormone function. And this particular presentation will focus in on thyroid function and female reproductive hormones. So to start with soy isoflavones and thyroid function, this was first established in cell culture and rat studies when it was observed that isoflavones can inhibit thyroid peroxidase by acting as an alternative substrate for iodine. There were also early reports of goiter in infants who were consuming soy infant formula that did not have sufficient iodine in it. But fortunately, this was eliminated in the 1960s with iodine fortification of that formula. With respect to isoflavones being an alternative substrate for iodine in the action of thyroid peroxidase, this particular human study is of great interest because its primary aim was to examine iodination of urinary isoflavones after postmenopausal women consumed 80 milligrams of isoflavones for 3 months. And their urinary isoflavones definitely increased 8-fold actually. Notable here is that less than 1% were iodinated, showing that any action that isoflavones may have as an alternative substrate for thyroid peroxidase in humans is minimal. And indeed, this study did not see any changes in thyroid hormones. In 2006, a narrative review was published that looked at the 14 clinical trials to date that had intervened with soy foods or isoflavones and measured thyroid hormones. The results of this review showed either no effects or modest changes in thyroid hormones, leading the authors to conclude that there is little evidence in euthyroid iodine-replete individuals that soy foods or isoflavones adversely affect thyroid function. These and other data led the EFSA panel on food additives and nutrient sources added to foods to conclude that administration of food supplements containing isoflavones, hypothyroidism, or congenital thyroid dysfunction, although they noted that these groups can consume soy foods as long as no more than the median Asian intake. This slide shows 2 studies that were completed in adults with subclinical hypothyroidism in 2011 and 2018 by the same research group that used a randomized crossover design and looked at the effect of soy protein isolate of 60 milligrams versus 2 and 66 versus 0 on thyroid hormones and progression to overt hypothyroidism in adults with subclinical hypothyroidism. In the first study of 60 patients, the researchers saw that 6 of them progressed to overt hypothyroidism, and they extrapolated this to a yearly risk ratio of 3.6. Now, they didn't see any changes in thyroid hormones. When they did another study in 2018 with 44 participants and a higher dose of isoflavones, they only saw 2 participants progress to hypothyroidism, and again, no significant differences in thyroid hormones. These studies do not corroborate each other and actually suggest that maybe more research is needed, and the idea that there was no effects on thyroid hormones is notable. It is well established that soy can interfere with the absorption of thyroid medication. This is also the case with many other dietary components. It's well established, and that's why thyroid medication is actually recommended to be taken first thing in the morning on an empty stomach and even avoiding foods for an hour afterwards. So overall, with respect to soy and thyroid hormones, to summarize, it's the cell culture and animal studies that established a role for isoflavones in thyroid function through inhibiting thyroid peroxidase. Although healthy iodine-sufficient human studies have shown that isoflavones may be able to serve as an alternative substrate for thyroid peroxidase, it's very minimal, and in fact, studies and reviews show isoflavones do not have any negative effects on thyroid hormones. In humans with compromised thyroid function, they are recommended to avoid isoflavone supplements, but moderate soy food intake timed around their medication is considered safe. And it is noted that more research is needed in this area. So then moving along to soy isoflavones and female reproductive hormones. This area is of interest because cell culture studies have established that isoflavones can inhibit the synthesis and activity of enzymes involved in estrogen metabolism. Like in the bottom right figure, the red circles, aromatase, 17-beta-hydroxysteroid dehydrogenases, and isoflavones can also increase sex hormone binding globulin synthesis. With respect to human clinical data looking at hormones, a 2009 systematic review and meta-analysis focused on this in both pre- and postmenopausal women. This slide shows the studies in premenopausal women, 11 of them, almost 600 women, with different soy food interventions, different durations, and they overall found no effects of soy on total estradiol, free estradiol, estrone, progesterone, or SHBG. However, as you can see from the standardized mean difference results on the left, that there was a decrease in FSH and LH.